I'll start into, it's very important and it's very apt for what we do, is we are a company that is making robotics accessible to the widest range of manufacturing. And as you continue to see the work that's going on in Andhra Pradesh and how they're leading in manufacturing, and it's very interesting because a lot of times people think robotics are just confined to your traditional Detroit or Tokyo, but it's really a technology that has spawned, it's going throughout the world and in fantastic manufacturing centers like we have in Andhra Pradesh. And so that's what we do at Soft Robotics. We're a global company. Our sales ops folks put this together, and I'm sure we can work to get some of those systems up and running in India. So what is the problem that we're trying to solve is the current robotics industry is very large, very meaningful, and growing at a very high rate, but it's still confined to what we call highly structured environments, and that's automotive and electronics. So robots either paint or weld cars, or they assemble phones, or they do silica wafer fab. And the problem is there's a lot of industries out there, if you think about consumer goods, retail manufacturing, logistics, the food supply chain, that are highly dependent upon manual labor right now, and manual labor is becoming more scarce every day in every part of the world. And so we've turned to robotics to solve this labor problem, but the robot that's very good at welding a car is miserable at handling textiles or at handling shampoo bottles and these other things. And so at Soft Robotics, we wanted to bring our novel Soft Robotics technology to really enable that. And that's what we do, is we work in non-traditional industries. We do a lot in the food supply chain, because just as every car being welded is the same exact car and the same exact weld, every piece of fruit, every piece of chicken in the world is different from the other. And so the unpredictability, the unstructured nature makes it a very difficult problem. High SKU manufacturing, fast-moving consumer goods. Once again, we're in a consumer-driven supply chain now. So the days of making a limited number of items and selling them into a store is now we have to make what the consumer wants, and that's a global consumer. And if you don't supply it, they will buy it somewhere else. And then we talk about e-commerce, but it's really the entire supply chain. So just as we're in this high SKU manufacturing, we now have to be in a high SKU delivery. And so we've put together a quick video here. I don't know if I can you click on it to play it? That just shows some of the applications. The technology is, it's a patented material where the robots are soft. We do build them out of polymers. We've got proprietary control algorithms that lets us program these in. So here's cherry tomatoes being moved at about 130 per minute. So that's 2 cherry tomatoes being moved per second without damage. And so our technology really is the polymer science technology. How do you build a robot out of polymers? And then how do you control it so that you can plug it into an industrial automation program and have something as amazing like this as high-speed packaging of tree fruit. This is a pizza factory. It's a refrigerator. Trying to find people to work in a refrigerator for 10 hours a day, hand packing dough, is a very difficult recruiting job. And so they turned to robotics, but having a robot that could do a high-speed handling of fresh dough was a problem. You can see we do a lot of work in produce. This is a line in the Netherlands right now. Berries, once again, farming is an industry that's under severe constraints from labor availability. And in the United States, 20 to 30% of the food that we grow is abandoned in the field due to a labor shortage. And so it really is a global tragedy that we can't get food out of the field into the supply chain and onto people's tables for dinner. One of the things that we like to do is with Soft Robotics, we tell them you can have a robot pick something up like a human. So traditional robotics, there's always been one right way to interact with an object. With Soft Robotics, there's near infinite ways. So you can pick it up from the top, you can pick it up from the handle, you can pick it up from the side, just the way we humans would pick things up. And so we'll run through just a couple more of these videos, and then we'll wrap it up from there. This is one of our favorite ones we did. Our intern built this to show that it really could act like a human, is you can build a circuit, actuate it, disassemble it, all with a robot now. And this is something that just a few short years ago never would have been possible. And so when we talk about high SKU manufacturing, here's something we like to do, which is we call it throw things in front of the robot. And so you really can throw these objects just as if you were in a logistics problem in front of the robot. It's going to handle them. It's going to handle them at high speed without damage. And this is the kind of capabilities that we can bring to solve these problems. And so with that, just to wrap it up, what we do at Soft Robotics is we bring human-like dexterity to industrial robots. We do it through material science versus the traditional electromechanical approach, and it creates an automation system that's plug and play to solve some of these largest problems. We do a lot of work in industrial. collaborative robots as we take off of robots working side by side with people. And then we're very interested in bringing that technology to a mobile robot, so now it can really move around a house, an elder care facility, a warehouse, and interact with all these objects that were designed for the human hand. What that boy. So thank you very much. I want to thank the organization for the invitation to speak, and I'll hand it over to Amit. Thank you.
Thank you very much, Carl.